So welcome everybody to this latest video on 162 Maths, and in this video we'll be looking at GCSE or KS3 trigonometry with a focus on angles of elevation and depression. Now when talking about the angle of elevation and depression, they may sound a little bit more confusing. However, if you put it in context of a picture or in reality, it's actually not that bad. Now the angle of elevation and depression all starts from a horizontal line of a viewpoint. So if I just draw this line here, this is me looking at an eclipse, then the angle of elevation starting from that horizontal line is the angle in which I'm looking up. So if I have this as my viewing line, this is my start line, so let's just label this. So this is my start line, and this is my, let's say, view line, not official. Then this here would be my angle of elevation. And we just call it E just for the elevation. It could be X, it could be absolutely any other letter. Now if we look at the angle of depression, again what we do here is we have a starting horizontal line. So imagine that this is my starting line, and the angle in which, or the angle of depression, is the angle in which I'm looking down. So if you imagine here that I'm looking at my phone, then if I imagine the angle, then this here would be my angle of depression. Again, we can label it D, you can label it whatever you want, but basically it's important that you establish the difference between the two. Now again, with both angle of elevation and depression, you're always starting from a horizontal plane. For angle of elevation, it's how much you look up. Angle of depression, it's how much you look down. Obviously, in a good way of remembering, although not very, quite a morbid way, is if you are feeling depressed, you are looking down. If you're feeling elevated, you are looking up. So now let's have a look at some example questions. Now when it comes to the angle of elevation and depression, whenever you see those words in a question, I would always recommend drawing a picture. Now it doesn't need to be a work of art, even though I do enjoy drawing and sketching and doodling. It's always important you don't take the focus away from the question, because obviously in an exam time is of the essence. So let's have a look at this question. So it says a point P is 90 meters away from a flagpole which is 11 meters high. What is the angle of elevation of the top of the flagpole from P? So if I just do a little quick sketch, just to try and get some understanding about what this question actually resembles. So here is my ground. Let's draw this flagpole. Okay. And let's just attach a flag to it. Let's draw like so. And so what this question is saying to me, that we've got point P, which we're going to say our point P is here. That's point P. And the question that we're asking for, we know that it's 90 meters away. So this distance here is 90. And the flagpole is 11 meters high. And what the question's asking me is, what is the angle of elevation from P to the top of the flagpole? Now again, if it was talking about the angle of depression, well, that would be this angle here. So this is the angle of depression, and this angle here is what I'm looking for, is the angle of elevation. Now if you are good with remembering your proofs of angles in parallel lines, then hopefully you should spot that the angle of depression is going to be the same as the angle of elevation, because they are both alternate angles. So it may be worth that, if you are making notes, to recognize that the angle of elevation equals the angle of depression, and the reason for that is because they are alternate angles, or Z angles as they used to be called in the past. So again, as always with these questions, we are diverting, so let's have a look at actually answering this. So what the question is asking me is to find the angle of X. Now in terms of this, if I relate this to trigonometry, which obviously it is going to be linked to, this question is just a worded version of this. So here is my X, that's 11 and that is 90. And that's what I'm trying to find, is what this angle here is going to be. So from this, again, go through the notions of labeling my triangle. So this is going to be the opposite, this is going to be the adjacent, so I'm going to be using tan. So then tan theta equals 11 over 90. So in other words, tan x equals 11 over 90. So angle x is going to be the inverse tan of 11 over 90. And on the calculator we get 6.968256.741, which rounded up gives us, I would say, let's do 2dp, 6.97 degrees to 2 decimal places. Now you might be thinking to yourself, well, that answer looks very, very small for an angle, but in theory, if you were looking at something far away, then how far do you need to tilt your head up to look at the top of that bit? Well, if it's quite far away, you'll need to tilt it a little bit to see the top. So although that angle is relatively small, in the context of this question, it seems like a valid answer. So let's move on to the next question. So the next question then says that a yacht, which is not a boat, is 20 meters from a lighthouse. From the top of the lighthouse, the angle of depression to the yacht is 48 degrees. Calculate the height of the lighthouse. So again, always worth drawing a little sketch of what this actually means. So here is our sea, and here's a little land. Excuse the painting for this. It's been a while since I've seen a lighthouse. And let's just quickly draw our yacht. Yeah. And so from this, let's have a look at what this all means. So the yacht is 20 meters. So this distance here is 20 meters. And it says the angle of depression is 48 degrees. So if I draw a horizontal line, that this angle here is going to be 48 degrees. And the question's asking us calculate the height of the lighthouse. So what the question's asking me to do is to find this distance here. So if I take that out in terms of the context of the question, this is x. I know that this angle here is 48, and I know that this distance here is 20. Now, as I mentioned previously, that the angle of depression is the same as the angle of elevation, so that's going to be 48. And again, from this, I can then work it out. So again, we label our triangle. So I've got O and A. So I'm going to be using tan again, which is just a pure coincidence. So here I've got tan 48 equals x over 20. So then x equals 20 multiplied by tan 48. And so type that into my calculator, I get tan times 20 times tan 48. And I get 22.2 meters or miles, whichever questions is taken. I don't know if I've got a little angle there, so let's just get rid of that. And I've rounded this up to 1 decimal place, and there is my final answer. So let's have a look at number 3. So number 3 is a sniper lies on the top of a cliff which is 300 meters above sea level and has a target in the air of 260 meters away at an angle of elevation of 53 degrees. What is the height of the target from sea level? Right, so again, let's just do a little sketch of what we are dealing with. So here is cliff, and here is water, and here is our little sniper. So, and here is our target. We don't know what the target is. We're not going to question what that target is. So here is our target, and so let's just start filling in the information that we know. So we know that this distance here is 300 meters, and we know that this target is 260. Now what usually happens with these types of questions is that diagonal distance 260 meters, or is the horizontal, is this distance here 260? Now because obviously it's 260 meters away, that isn't going to be 260 meters away, it's the diagonal length that this means. And what this has also told me that the angle of elevation is 53 degrees. And what the question's asking me is, what is this entire distance here. Now, as you can see, what I'm going to do is I'm just going to take that right angle triangle out, because it is going to be a right angle triangle. And let's have a look at the information we've got. So we know that this is 260, this is 53. And now x, which is what I'm trying to find, well, I know that part of x, which is distance here, is going to be the length or the height of the cliff. So that's going to be 300. So what I then need to do is work out what this distance here is, which, looking at my right angle triangle, is that there. So again, using trigonometry involves angles and lengths. So here I'm going to label my triangle. So I've got, let's use difficult a pen. So I've got H, I've got O, and I've got my theta. So here I'm going to use sine. So I've got sine, just write down the formula. So I've got sine 53 equals x over 260. So x equals 260 times sine 53. And again, if I just quickly type that into my calculator, 260 times sine 53, and it gives me an answer of 207.64522326. Is that my final answer? No, because that number I've just worked out is just the distance, or the vertical distance, of the target away from Little Sniper. So what I now need to do is add these two numbers up. So the total, the height of the target from sea level is going to be 300 plus that number that I've worked out, which gives me 507.6 meters to 1 decimal point. So let's now have a look at quite a common question, but quite a complicated one. But again, it's only complicated because we don't have an actual diagram to represent this. So it says, standing on a cliff, maybe the same sniper, we don't know. Standing on a cliff 380 meters above the sea, Pat sees an approaching ship and measures its angle of depression, obtaining 9 degrees. How far from shore is the ship? So again, let's just do a little diagram of what we're looking at here. So here is our cliff, and here is Pat, and let's just draw our water, and we're going to assume that shore is here. Now also what we're going to do, let me just get rid of that line. So we're going to have to assume that Pat is standing right on the edge, and that this length, the cliff, is a perfect perpendicular to that sea level. And this length here is 380 meters. And we've got a ship. Right, so from this, we know that the angle of depression, so this angle here is 9 degrees. And we want to work out what this length here is. So again, taking part A, so we're going to take the triangle out. And this is 380, this is x. Now we know that this angle here is 9, so that means this angle here is going to be 9. So labeling the triangle, it's going to be tan again. So we've got tan 9 equals 380 divided by x. So here we're going to do 380 divided by tan 9 equals x. And again, working out what x is, I've got 380 divided by tan 9, and that gives me an answer of 2,399.22556, which will just round up as being 2392 meters or miles, whichever with 5 meters. Now, part B then says that Pat sights a second ship beyond the first ship, and the angle of depression is 5 degrees. How far apart are the two ships? So let's use the same diagram. Let's just draw our second ship. So here is our second ship. and this angle, so we'll use a different colour, and this angle here is 5 degrees. So for B, what I then need to do is to work out what this distance here is going to be. We'll just label that as y. I'm just going to move the question down a bit. So taking that question out, so for B, I know that if this is 5, then that's going to be 5. The cliff is still going to stay the same height, and it's this distance here that I'm wanting. So again, I'm going to be using tan. So from this, we then know that tan 5 equals 380 divided by y. So y equals 380 divided by tan 5. And if I type that into my calculator, 380 divided by tan 5, and again we're expecting an answer that's bigger than the other answer, so y equals 4343419875. Now the question's asking for the distance between the two ships being apart, so it's this which is the difference. So to find the difference, what I need to do is do y take away x. So y is 4343.419. Take away 2399.22, whatever the number is. And again, sometimes it's always good to be sort of accurate, but we don't need to be extremely accurate. Just a few decimal points after places will suffice. 2399.225, and we get an answer of 1944.2 meters, and that's to 1 decimal place. And there you go. So when dealing with angles of elevation and depression, these tend to be more worded questions, and I strongly recommend that you always draw a diagram to gain your understanding of what the question is. And once you've drawn a diagram, if you're not too sure quite what it is you're actually looking for, then I'd always seek help, particularly if you're in a classroom or even in an exam. Maybe not an exam because they don't really help you in official exams, but they may be able to give you some idea of what it is you're trying to find. And the more questions you practice of this topic, the better you'll become, just like with everything in maths. You just become more familiar with what's expected of what gets asked, but also these tricky questions that you may not understand straight off. By asking for help, you then know for next time.